disco party. Now I want you to know that I grew up in the 70s. Okay? So I had the clothes for the 70s. I had like this, my favorite shirt was this, it was like this silky shirt. It had clouds on it. And then we had bell-bottom pants and then had a couple pair of bibs that I wore.
Oh no.
So.
On the last day of Cal class, can we have a or the day after our AP exam.
That's the day of the exam. I will not dictate how you dress. See you, Harry. Okay.
I think we should bring the heater like tomorrow.
And keep it here forever.
Yeah.
All right. So yesterday we got an introduction to techniques of integrating these indefinite integrals where it's a little bit weird, and our normal techniques may not work. Okay, and so we're going to pursue that more. It all has to do with the Trojan horse concept, or the fact that when we did the chain rule, there's something inside of something else. Okay, and that's what I need you to be able to start watching for it, so you can recognize when you would apply U substitution and when you don't need to. Okay, so we're just adding another tool to our tool chest that allows us to integrate something that we couldn't have been able to integrate before. All right, so I want to make sure we do a quick recall. Okay, recall the fact that you can use any variable, but for the U substitution, we get in the habit of using U. So standard, if I gave you something like this, 1 over U squared du, okay, go get me the answer to that. What's the integral of 1 over U squared du? And let's just do one more over here. What about the integral of 4 secant squared u du? We're going to use u as our variable for this whole thing, so I just need to get you comfortable with using u. The first one you have to rewrite, correct? Got to write it like this, and then you can go ahead and integrate just like normal, and then you just rewrite it so it's good. This one here, integral of the secant squared of u, tangent of u. So this is just 4 times the tangent of u plus c, put in parentheses if you want to. Just noting that if you take the derivative of this, you get this. And if you take the derivative of this, you get this. Okay? So that's the connection. These are the antiderivatives of those, and we just happen to be using u. Okay? All right. So that's just intro. So now let's go on to this one right here. We're doing the integral of the cosine of 3x. Okay? Integral of the cosine of 3x. So what you may, if we think about how we would have started it yesterday, you know, when we were just like exploring it, you might say to yourself, now don't write this down, you might say to yourself, well, bless you, what's the integral of the cosine? Just the sine. So the question is the answer to this the sine of 3x plus c? Don't write this down. That's your hint. Okay? No, it's not. And the reason is, what's the derivative of the sine of 3x? Cosine of 3x times 3, right? Which is not what we have here. We have this extra 3 going on here. So somehow we have to compensate for that. And that's what U substitution does. It figures out how to do that compensation. So I'm going to teach you the technique. It's the same as it was yesterday. So what we do is we use the Trojan horse. So we say, if I let u equal 3x, okay? If I let u equal 3x, then I can rewrite this, instead of using x's, I can rewrite it using u's. And it would become this. This is the integral of the cosine of u, okay, where u is equal to 3x. Okay, it's a displacement going on here. But the problem is, don't write this part down, you can't write dx here. Okay, that's no good. Because u is the variable. X is no longer the variable. Just like over here, these were u's and du's. Okay, so this is no good. What I have to do is I have to figure out how to translate the dx to be a du. Okay, that's the reason why we got to do it. So, fortunately, we have this equation over here that we can manipulate. Since we know that the relationship between u and x is this, we can take the derivative of both sides of this, and we actually get the connection. So, watch this. The derivative of u with respect to x is du dx. We did this all the time with dy, you know, y equals, and then dy dx. So the derivative of u with respect to x is du dx, and it's equal to just 3. It's the derivative. But the powerful thing here is that we said that these little guys here are called differentials, and we can separate them. Which means I can actually do this, which is kind of cool. I can say, well, I'm going to multiply this side by dx and this side by dx, and the dx's cancel. And now we have a relationship between du and dx, such that du is equal to 3 times dx. You see it? Now, the only thing is, I want to replace dx, okay? So that means I got to solve this for dx. So the way I'm going to do is just divide by 3. So I'll write it as 1/3 du is equal to dx. And that's going to be the thing that I do their substitution, or that's where the U substitution also comes in. So in place of dx, I can write its equivalent as 1/3 du. So this becomes this, 1/3 du. You see the substitution? We did actually 2 substitutions. One for the 3x to become u, and one for the dx to become 1/3 du. Okay, now look at this. This is actually like one of these basic ones over here, just happens to be used in u's now rather than x's. So look at this. I can write this as, I can pull out the 1/3, that's the constant, and then the integral of the cosine of u is the sine of u. Okay. plus the constant. And then since we started with x's, we have to end with x's. So now we replace the u with the 3x, and we're done. So 1/3 sine of sine of 3x plus c. And it works every time as long as you follow the steps. If you find the derivative of this thing now, the answer is the cosine of 3x. It's automatic. Make sense? This is we've done now 2 of them. They're just the basic concept, and then we're going to just keep on doing more and more where they get just a little bit more complicated each time. Okay, let's take a look at another one. Okay, what about this one? The integral of x times the square root of x squared minus 4. With the tools that we have right now, without U substitution, this is impossible. We can't integrate this by hand. We need this extra tool to be able to do this job. Okay? So, the first thing you look for is you look for the Trojan horse. So who's inside of who? Just take a guess. What do you think u is? Yeah? X squared minus 4. Anybody else thinking that? Okay, x squared minus 4 is correct. Okay. Now we're going to see how the whole thing plays out, because this one's more complicated than the other ones. So watch what I'm going to do here. So I'm going to rewrite this as the integral of the square root of u, and I'm going to write everything else down, even though it's not the correct notation. Okay, because you're going to see why. So this is the same as this, as long as we know that u is equal to x squared minus 4. Okay, it's still the same problem, it's just rewritten with this. The only problem is I got to try to figure out how to convert this x dx into something that contains u. You find the derivative of that equation. So you get your du dx, and then you see how it works out. Okay, so let's do that. So this becomes du dx. That's the derivative of this equation, and that's equal to 2x. Okay. All right, let's do our little thing. We multiply both sides by dx. And we get du is equal to 2x dx. And that just means 2 times x times dx. Okay, do we have anything here that could match this? Yeah, x dx, so I just have to get rid of the 2. So I'm just going to divide both sides by 2, and I get 1/2 du is equal to x dx. Bad ellipsis. Okay. So now look at what happens. We're at the moment where I needed to fix this part because you can't have x's when we're converting over to u. So I'm rewriting this as the integral of the square root of u, but now it's going to be multiplied by 1/2 du. You see that? So I'll just rewrite this before we go ahead. This is what's really weird. The answer, this integral right here, is exactly the same, and it's equivalent to this integral right here, even though they don't look alike. Just because we chose u to be x squared minus 4. Okay, these are the same integrals. It's crazy. Okay, so let's do this. What's the integral of a square root? That one's one that I want. Should be, well, go get it. What's the integral of square root of u? You're used to being on camera, though. All right, you get, what do we get? 2/3 times u to the 3/2? Okay, good. So it's 2/3 times u to the 3/2 plus our constant. Okay, and then we wrap it up. I spy the 2's canceling. Okay, that's the same as 1/1. And so I'm going to do the final substitution. We got ourselves a 1/3. We got an x squared minus 4. That's replacing it. The 3/2 plus a constant. Does that make sense? So the process is always the same. It's just like what you're choosing for u, and it makes a big difference. If you find the derivative of this thing right here, you actually get this. You get what you started with. Okay? That's the relationship between those two. Okay, let's keep going. Integral of sine to the 5th power of x times the cosine of x dx. Without the tool of the U substitution, this would be impossible. So that's why this is a good new tool for us to have. Okay, so your first job is really to decide whether or not it's a U substitution, because after we're finished this unit and you have to integrate, you don't know, they're not all like compartmentalized into, these are all U substitution problems. You're going to have to decide, ooh, do I have to use it? Do I not have to use it? Okay, so any guesses what U should be? Is there a Trojan horse in this one? Is something inside of something else? Sine of x is correct. Okay? Now, if you don't see it, I'm gonna rewrite this just so you can. This actually can be written as the sine of x to the 5th power times the cosine of x dx. Okay? That's actually how you should view this when you see the 5 here. This is what it means. So what this is, it's the integral of u to the 5th. Okay? U to the 5th. And then the only thing is we just have to figure out what to do with this. But this one actually doesn't turn out to be too bad. So we do the work here. Du dx is equal to the cosine of x, and du is equal to the cosine of x dx. So do you see why this one's not too bad? Boom, that just becomes du. So it's u to the 5th You can think of it as times du to help. And then look at this. This is your base. This is a basic one. It's just u to the 5th du. So the answer is u to the 6th divided by 6th plus our constant. So that's a piece of cake. And then you just replace it. Go back to x's. So it's 1/6, and it's the sine of x to the 6th power. So I'm just going to write it in our normal way like this, plus our constant. And that's all there is to it. Does that make sense? Okay, I'm going to give you one, and you just do this one right now, and then we'll try a harder one. Okay, you do this one. What are we up to? Number 4. Integral of 3 times, well, let's make it 3x squared times, I'm going to make it just x squared times x cubed plus 5 dx, and we're going to make this to the 10th power. Okay? Feel free to expand it if you don't want to do a U substitution. Okay, do we agree? Any questions on how I got there? It's all about choosing u properly, and then doing the substitution, doing the derivative, doing the substitution, doing the integral, and then unpacking it. Just several steps. They're not too bad. Okay, all of these that we've done so far are all indefinite integrals. Okay, so moving on, what happens if we turn this into a definite integral? So we'll start off easy. We'll go the integral from 0 to 1 of x times x squared plus 1 to the third. Okay. The only difference that we have here is that after you do all this, then you have to evaluate it at 1 and evaluate it at 0. You know what I'm saying? Okay, you go for it, and then I'll do it up here in a little bit. Now this might be, like, this is the new part. You see I didn't write the plus c. Anytime you do the definite integral, you don't have to write c, because it's going to subtract off anyway. Okay, so we don't have to write the c here, but we always have to write the c here. Okay, so then notice that it's the evaluated from 0 to 1. So this becomes this, and I had to go back to x's to be able to do that. Okay, that's a great question. That's exactly where we're headed next. Okay, and because there's a moment in here where things got weird, and let me explain why why it's weird. And Sam's addressing it right there. The original problem has x's in it. So when I do this, I do know that this is for x equal to 0 to x equals 1. Okay? Because the problem had x's in it. So this is like no problem. We've done dozens of these now. Okay? But as soon as we convert it over to a u, this is when it's weird. Okay? And the reason why it's weird is because 0 is still an x, and 1 is still an x, but then we're in u mode here. You see what I'm saying? So at this mode, it's like we're going through a portal. Okay? And same thing with here. This is an x equals 0, and this is an x equals 1. So this is also weird right here, and then we're back to normal here. See what I'm saying? So through this phase right here, you can just go with the flow, knowing that we're actually have our one foot in two different worlds, the u world and the x world. Until we get back to here, then we're good. Now, I'm going to show you a technique which is called change in variables, which is actually where it extends this. So let's do that right now. So I'm going to handle the same exact problem, but I'm going to get rid of the weirdness. Because there's not going to be a moment where we're kind of living in two worlds. So check this out. It's actually kind of cool. So it's the same exact problem. And so I'm going to start with the original problem. This is 0 to 1, x times x squared plus 1 cubed dx. Everybody's in x's. Okay. Now, when I rewrote this as this, I said this is the integral of u to the third times 1/2 du. That's still fine as long as u is equal to the x squared plus 1. Okay, so we know that u is equal to x squared plus 1. Okay? So this is okay to here, but I just struggle with putting an x there of 0 and 1. Okay? But wait a second. We know the relationship between u and x. It's right there. This is a translator. It allows us to translate from an x to a u. In other words, I don't have to go to this weird place here. I can say, well, instead of going from 0 to 1, where those are x's, I can go from a number to another number, but in u's. And I'm going to show you how you get the same answer. It's pretty cool. So what I'm going to really do is I have to evaluate this. Essentially, I need to find out what's u of 0 and what's u of 1. It's a translator. How do you go from an x to a u? Okay, very carefully. 0 squared plus 1. So when when x is equal to 0, u is equal to 1. Likewise, when x is equal to 1, u is equal to 2. So what that means is the integral from 0 to 1 of this x expression is exactly the same as the integral from 1 to 2 of this u expression. And nothing's weird. Now watch how this works. It's actually really cool. You go here and you say, okay, let's do the integral. it's 1/2, and then we do the thing. It's 1/4 u to the 4th, and it's evaluated from 1 to 2. Same as we did before, but once we go to u's, we're never going back. Okay? So this becomes, look at, it becomes 1/8 times, because it's 1/2 times 1/4. U to the 4th means 2 to the 4th minus 1 to the 4th. And the answer is the same. 16 minus 1 is 15/8. The final answer is the same, even though how we got there was 2 different ways. This has a name, and it's called change in variables. Squeaky. Okay, so whenever you hear change in variables, that's what we're doing. We're changing the variables. Kind of makes sense. Okay. Now, here's what I've known to see on the AP exam. They give you this, and instead of saying, tell me what the answer is, they say, tell me what its equivalent is using change of variables. And so you would say, well, this is the same as this. Because there's a lot of mistakes that can be made as you go from here to here with that. People, and one of the common mistakes is they'll say, they'll have this as one of the options. Okay? And that's wrong, because these are x's. The 0 and the 1 are x's, and this is saying it's the same as those being u's. Not so, because this is the correct answer. See the connection? Okay. Now, so we've done now indefinite integrals, we've done definite integrals, we've done change in variables, and we've done kind of complicated ones, but I'm going to give you the hardest ones we can tomorrow. Today's Tuesday. This homework assignment is due Wednesday, and it's super important that you get this one done. I probably due Thursday. Sorry. Big sigh of relief. Okay, so due Thursday.